Hello everyone. In the previous videos, I created a full series showing you how to design and build a multi-purpose ECU bench power supply connector. In those videos, we worked step by step to design the complete circuit. Our system is divided into two main sections. The first section is the protection circuit. It includes short circuit protection and reverse polarity protection for the input power. The second section is the simulation circuit. This part recreates how a vehicle supplies power and how an ECU operates in real conditions. In today's video, we will move to the final step, which is assembling and completing the entire unit. As you can see in my hand, this is a plastic enclosure that I use to install and protect all the components inside. To save time, I have already prepared the mounting positions for all necessary parts, such as the OBD connector, the power input jack, the control switch, status indicator LEDs, and other components. You can customize this layout based on your own needs. The most important thing is to make it easy to use, easy to access, and convenient for your workflow. Now, let's start the assembly process. As mentioned earlier, our system has two main sections. So first, we will assemble the protection circuit. This circuit uses a 5-pin relay with both normally open NO and normally closed NC contacts. First, I will fix the relay into its position inside the box. Next, we will start wiring based on the circuit diagram. Here's a small tip. Use a marker to label the points you have already connected. This helps you avoid mistakes and makes troubleshooting easier. Now I connect the positive input voltage, B+, to the COM pin of the relay. For the input power, I use a detachable connector so it is easier to connect and replace. Next, from the COM pin, I route the line through a diode and then to the switch. The switch used here is a momentary switch. It only connects when pressed and disconnects when released. The diode plays an important role here. It provides reverse polarity protection for the input power. After that, the other side of the switch is connected to one side of the relay coil to activate the relay. Next, from the same point between the switch and the relay coil, I connect a wire to the NO contact of the relay. This creates a self-hold circuit, which keeps the relay energized even after we release the switch. At the same time, this NO point is also used as the B plus output. Now the B plus circuit is complete. Let's move on to the B ground circuit. This part is simple. The B line is connected directly to the remaining pin of the relay coil and also used as the output ground. Next, we connect the LED indicators. The indicator light connected to the NC contact of this relay is the short circuit warning light. I will use a red LED for this position. And for the LED installed at the output power position, I will use a green color. I connect all LED negative terminals together. Compared to the original design, I made a small improvement. Instead of using two separate resistors, I use one resistor for the shared negative line. This makes the wiring simpler while still keeping the circuit safe. For the positive side of the LEDs, one LED is connected to the B plus output to indicate power on. The other LED is connected to the NC contact of the relay to indicate protection or standby status. Now the protection circuit is fully assembled. Let's test it. I use an external power source to supply the circuit. When power is applied, the red LED turns on. This means the relay is not active and there is no output voltage indicator. You can confirm this using a multimeter. Now I press the switch. The red LED turns off. The green LED turns on. This shows that the relay is activated and the contacts are closed. At this moment, the output voltage is present. Next, I test the short circuit protection. I intentionally short the output. The circuit immediately cuts off. The relay is released. Output voltage is removed. This is a very important feature when working with real ECUs. Now let's test the reverse polarity protection. When I reverse the input power, no LED turns on. The relay cannot be activated. After measuring, we can see that the voltage stops at the diode and does not reach the relay coil. This is due to the one-way conduction property of the diode. As you can see, this circuit is very simple but highly effective and practical. After completing the protection circuit, in the next part, we will move on to assembling the ECU power simulation circuit.